Take 60,000 tons of steel, 260,000 cubic meters of concrete, 2,000 dedicated Chinese workers, and some of the best design brains in the business. And this is what you get. The Shanghai World Financial Center. Nearly 500 meters tall, and every meter state-of-the-art. Designed to be strong enough to stand up to killer typhoons and powerful earthquakes, and to withstand the ultimate threat by a world-renowned engineer still haunted by his most famous building's horrifying fate.
I don't think I ever got through the experience of 9/11.
When this megastructure's finished, the world will marvel at a skyscraper like no other, a dazzling icon of China's rise to power. China, the world's fastest growing economy. Shanghai, China's biggest city, the financial heart of its economic miracle. Along the Huangpu River, grand old buildings evoke the jazz age of the 1920s, when foreign powers had made Shanghai their Asian financial headquarters. And Shanghai's highest building was just 9 stories tall. That was then. This is now. Welcome to Pudong, Shanghai's hottest real estate, ground zero of China's economic clout. A forest of skyscrapers proclaiming Shanghai's drive to become Asia's financial capital. Pudong's icon, the Jinmao Tower, a state-of-the-art office building and hotel completed in 1998. 88 stories high, 5th tallest building in the world. But there's a new megastructure rising on Pudong's block. It's not even finished, but already it's putting the Jinmao Tower in the shade. 2,000 workers are toiling day and night to build the Shanghai World Financial Center. And they won't stop until it's 101 stories tall, soaring nearly 500 meters into the sky. The tallest building on the Chinese mainland, and the 3rd tallest building in the world. 17,000 people will work inside its 70 office floors, topped by a 14-story luxury hotel, and crowned by the world's highest observation deck. Building anything this big is not for the faint of heart. In New York, some of the world's best architects and engineers forgot about sleep and tackled the toughest challenges planet Earth can throw at a skyscraper. And even deadlier human threats. Now, in Shanghai, a team of construction workers is turning the designer's vision into a reality. They've come together from all over China, proud to be part of one of their country's greatest building projects. But everyone working here takes risks, and many pay a price. Like Deputy Manager Bernie Ren, who goes home to Hong Kong just once every 3 months.
The big impact on me right now is I miss the opportunity of seeing my son grow up. He misses me very much. He calls me a lot. Every time I go back to Hong Kong, he always sticks around me, and we are very happy spending time together.
Bernie's responsibility is quality control, making sure that work stays on schedule, but safety's never compromised. Today, his job's taking him all the way to the top. It's early morning, but construction isn't starting because it never ends. On this site, work goes 24/7. These workers are just the day shift, and their commute is not for the timid. The only way to get to work is in lifts bolted to the outside of the building. It's a great view, if you don't mind looking down. Heights don't bother this man. Chen Shuifu works even higher than the top floor workers. 40 meters higher. He runs the Favel Favco M900D, one of the most powerful high-rise construction cranes in the world. Without Chen Shuifu and his crane, this 90-story megastructure would still be a hole in the ground. Because building it starts with steel, lots of steel. It takes 650 tons to build just one floor. That's the weight of 90 elephants. Multiply that by 101 floors, and you get over 65,000 tons of steel. That's 10 times heavier than the Eiffel Tower. And as the building gets taller, steel has to go higher, a lot higher. Construction's now past the 400-meter mark, up to the 91st floor, only 10 floors short of the top. To build those final 10 floors, 6,500 tons of steel need to get from here to there. And that's where Chen Shuifu comes in. He and his fellow crane operators hoist multi-ton beams over 400 meters. Their shifts run day and night, and no one ever knocks off early.
The World Financial Center is the biggest project I have worked on. Usually we start work at 6 a.m. We bring some bread and noodles for lunch. We finish work at 6 p.m. So we work a total of 12 hours a day.
Now that the financial center's over 90 stories high, Chen Shuifu does his job hundreds of meters in the air. But when construction started, he worked just above street level. His crane anchored to the basement. How does a 250-ton crane stay higher than the skyscraper it's building? That's one of the most amazing things about the M900D. This mega crane doesn't just lift enormous beams of steel. It can also lift itself. As the building rises, it rises too. By jacking up its tower with powerful hydraulic rams and inserting new tower sections. To do that, those jacks have to push a 250-ton crane 40 meters straight up. But to work at these heights, a crane needs to be more than just strong. It has to be fast and smart. The M900D definitely fits the bill. These cranes don't flinch at lifting 32-ton loads 400 meters up at 36 meters per minute. In fact, 400 meters is child's play. The M900D's hook hangs from a wire rope that's 750 meters long, the length of 10 jumbo jets. And this crane has a brain. Its drive system knows when there's nothing on the hook and gives the okay for the hook to go full speed to the ground. When the hook's got a full load, it's a different story. The motor switches to full power and pulls huge hunks of steel hundreds of meters above the ground. At heights like these, you definitely don't want to drop a multi-ton steel beam anywhere except where it's supposed to go.
The hardest thing about operating cranes on this building is that the beams are longer than usual. How long a beam is and how far it hangs out are the factors which can make operating a crane difficult.
Every time he lands a beam safely on top, Chen Shui-fu can relax for a moment. But the new arrival gives others plenty to worry about. A team of expert steelworkers must now wrestle the giant beams into place and bolt them together. One of those steelworkers is Zhang Shouliang. He spent years working at one of China's biggest shipyards, with both feet firmly planted on the ground. When he came to work at the World Financial Center, he found out fast that 400 meters up in the air, working with steel, calls for nerves of steel.
At the beginning, I was nervous, and my hands and feet were shaking. After a while, I managed to overcome it. To someone starting this job, I would say, safety first on the first day. Be careful when climbing up and down the ladders and scaffolds. Safety is first and foremost for you at this height. Because only when you are safe can your family be happy. If you have an accident, your whole family will bear the consequences.
Safety is Bernie Ren's biggest worry. He's come up top to keep an eye on everything. But he's also feeling the excitement. He's been working on high-rise buildings for over 23 years, but on this job, he's helping make history. And that takes a little of the sting out of being far from home.
My son is 13 years old. Before I came here, he asked me what project I was working on this time. I told him I was going to Shanghai to work on the World Financial Center. And he just said, "Oh."
As the workers pass 400 meters, they're heading into unknown territory. In mainland China, no one has ever built as high as they are going. And the Chinese building code stops at 350 meters. They're literally moving off the charts. And there's still nearly 100 meters to go. As they close in on success, it's hard to imagine how many challenges blocked their path, and that this magnificent structure once seemed doomed to fail. 1990, China's central government announces plans to transform an aging Shanghai suburb called Pudong into a gleaming financial center. And Japanese real estate tycoon Minoru Mori gets an idea. Mori envisions a mega building that will dominate the new Pudong skyline and rank among the tallest buildings in the world. To pay for his vision, Mori raises a whopping $625 million. To design it, he turns to some long-trusted associates, the world-renowned New York architects of Cohn, Peterson, Fox. Lead designer William Peterson had a challenge on his hands.
This was going to be a super tall building which had to deal with the very interesting issues of the connection of earth and sky, which a tall building has to do. It needed to be a building of great nobility.
Peterson discovered that in ancient Chinese culture, Earth was square and sky was round. His design blended both shapes into a soaring 95-story prism of steel and glass, lifting the eye and the soul from the earth to the heavens. It was lovely, but no one could build it until its designers solved one big problem. Pudong may be million-dollar real estate, but it's also a very bad place to build a very tall building. River water saturated soil, turning it into unstable mud. When building crews pump the water out, the land sinks. Since 1920, parts of Shanghai have sunk almost 2 meters. At Kohn Pedersen Fox, senior designer David Mallet knew construction couldn't proceed until the design team successfully grappled with Pudong's less-than-ideal geology.
Shanghai is all alluvial soil, so there's not quite the bedrock that you would find in Manhattan. Manhattan, you go down one floor and then you're sitting on granite.
The team's solution: if they couldn't build on granite, they'd use a simple but effective device to anchor their skyscraper in mud. Friction piles. 2,000 steel rods driven 80 meters into Pudong's swamp. The deeper the piles push into the mud, the harder the mud pushes back, gripping the rods tightly, creating a stable foundation. Floating the World Financial Center like a ship on Pudong's waterlogged soil. 1997. Construction of the Shanghai World Financial Center begins. But no sooner is the foundation finished than disaster strikes. 1997. Asia's overheated economies collapse. The meltdown paralyzes the Japanese banking system and suddenly floods the Asian real estate market with unoccupied office space. The last thing China needs is a $625 million empty office building. Some of the financial center's investors pull out. Construction grinds to a halt. 5 years pass. What was to be the pride of Pudong appears destined to remain a gigantic hole in the ground. But by 2003, Asian economies are roaring back. Minoru Mori finds new investors for his mega building. In New York, the financial center's architects get another call. The good news: their masterpiece is back on track. The bad news: its design no longer works. When construction started in 1997, the world's tallest building was Malaysia's Petronas Towers, 88 stories high. The 95-story World Financial Center was on track to take the title. But by 2004, a new skyscraper, Taiwan's Taipei 101, soared 101 stories, or 508 meters, above the earth. Minoru Mori told his architects Shanghai's tallest skyscraper must rival Taipei 101. No problem, except the World Financial Center's foundation was already built to support only 95 stories. Adding 6 more stories meant extra weight pressing down on a foundation that couldn't support it. And that wasn't all. China was now the host of the 2008 Olympics. Minoru Mori didn't just want a taller building. He wanted it finished before the world turned its eyes on China in 2008. In New York, senior designer David Mallet went back to the drawing board and stayed there well past closing time.
You have to be 100% dedicated to the task, for sure.
Across town, legendary structural engineer Leslie Robertson and his team rolled up their sleeves and went to work.
Our challenge was to come up with a building that was larger, taller, so it needed to be stronger and it needed to be lighter. And it had to stand on those existing foundations.
Robertson's larger, taller, lighter solution was an engineering triumph. Its secret? Modular design and the outrigger truss. Steel beams radiating out from a concrete core. Attached to a diagonal braced frame. A modular design requiring less steel to build. And repeating itself every 12 stories. What looked like a single 101-story building would actually be a series of 12-story buildings stacked on top of one another. Easier and faster to build, giving the builders a shot at finishing before the 2008 Olympics.
So this way we got faster construction and more economical construction while maintaining structural integrity, robustness, and all those good things.
June 2007, 4 years after construction restarted. Thanks to its modular outrigger truss design, workers are building the World Financial Center at a rate of 1 floor every 3 days. At the top, the steel crew bolts in floor plates, completing the skeleton of the 91st floor. Meanwhile, the cranes are lifting a much lighter, but critically important, load to the 90th floor, where another team begins the back-breaking task of installing 10-meter lengths of rebar over the steel floor plates. Rebar stands for reinforcing bar, and it's used in buildings all over the world to reinforce concrete. It takes over 150 kilometers of rebar just to cover one of the financial center's floors. That's over 15,000 kilometers for the whole building. If you laid that much rebar end to end, it would reach to the International Space Station and back 19 times. Next step, pour the concrete. 90 floors below, what looks like a giant praying mantis seems ready to attack the World Financial Center. In fact, it's a concrete pumping machine. When the rebar's ready, workers 400 meters high will need massive amounts of concrete pumped up to them. To pull that off, you need some of the most powerful concrete pumps in the world. And believe it or not, this monster isn't one of them. It can only pump concrete as high as its arm can reach, close to 40 meters. The real action starts after dark, when concrete trucks line up to feed 3 small machines. They don't look like much, but these pumps are the real deal. So powerful, they can shoot concrete nearly 500 meters into the air through this pipe that runs across the bottom of the building and then straight up to the 90th floor. When these pumps fire concrete skyward, it sounds like one unhappy dinosaur. When it pours out on top, the concrete crew breathes a big sigh of relief. And so does Deputy Manager Bernie Wren.
Pumping concrete from the ground to the top of the building takes a long time. And if we don't mix it right, the concrete will set inside the pipe and we'll waste a lot of time searching for the blockage.
You could fill an Olympic-sized swimming pool with the amount of concrete that covers just one financial center floor. For this crew, midnight is only lunchtime. They started at dusk, and they won't be done till dawn. All this steel, rebar, and concrete looks mighty impressive. But will the redesigned World Financial Center really be strong enough? Geologically speaking, it's in a pretty rough neighborhood. China is one of the world's most dangerous earthquake zones. Shanghai isn't the riskiest seismic area, but a strong earthquake could shake Pudong's waterlogged soil until it liquefied, and even well-anchored buildings could collapse. As dozens did during Japan's devastating Kobe earthquake, which struck just over 1,300 kilometers northeast of Shanghai. The financial center's new design had to satisfy this man. Professor Shi Liu of Shanghai's Tongji University. He and his team of engineers run China's largest seismic shake table, subjecting scale models of skyscrapers to massive simulated earthquakes to see if they'll survive.
All of these structural systems are new. They had never before been used in the construction of a building reaching 492 meters. Not only that, the size and structure of this building all exceed the limits of the current Chinese design code. So detailed and specialized analysis needs to be carried out.
For 3 days in 2004, Professor Shi and his team hit a model of the Shanghai World Financial Center with a simulated magnitude 7 tremor, almost as strong as the Kobe earthquake. If it failed, construction might have to halt, while the Olympic countdown clock kept on ticking.
Through detailed analysis and experiments, we have concluded that this building can sustain a 7-degree earthquake.
Architects and engineers met the challenge of putting one of the world's tallest buildings on a foundation that wasn't built to hold it. But there were still plenty of challenges to come. After the steel, rebar and concrete, you'd think the toughest parts of building this megastructure would be over. But one of the hardest jobs of all